Okay, so the next question is question number 15, which is basically exercise 15. The question is, let R be the relation in the set. Let R be the relation in the set basically 1, 2, 3, and 4 given by well, R is equal to, let's call this set A, for example, and R is equal to 1, 2, 2, 2, and 1, 1, and 4, 4, and 1, 3, and 3, 3, and 3, 2. So this is the relation. You want to choose the correct answer. To choose the correct answer, it's actually a little bit unusual to have basically to pick an answer in mathematics. I've never actually seen that before, but choose the correct answer. Now there are 4 options here. I don't even remember the name of such tests anymore. I don't even remember the name of this sort of test. So R is reflexive and symmetric. R is reflexive and symmetric, but not transitive. Choice B is R is reflexive and transitive. R is reflexive and transitive, but not symmetric. Choice C is R is symmetric and transitive, R is symmetric and transitive, but not reflexive. And choice D is R is an equivalence relation. R is an equivalence relation, meaning that it's reflexive and symmetric and transitive, right? So now, in order to figure out which one is the case, so basically in order for R, first of all, we need to know whether R is basically, in order to figure out whether, for example, let's say R is, for example, symmetric or not, or reflexive or not, the condition for that is that A, A has to belong to R for all A belonging to A. Which means that basically since A has 1, 2, 3, and 4, 1, 1 has to be there, 2, 2 has to be there, 3, 3 has to be there, and 4, 4 has to be there. So that means that then R is actually reflexive. So R is reflexive. Now based on this, we can rule out a couple of options here, I suppose. So here we are saying R is reflexive, not reflexive, so this is not the case. And here we don't really know much about this here, but now any of these three, A, B, or D, can be the answer. Now let's see if R is symmetric. To figure out if R is symmetric, the condition is that if A1, A2 belongs to R, that implies that A2, A1 also belongs to R for all A for all A1 and A2 belonging to A. That is the condition. That means that if A1, A2 belongs to R, A2, A1 has to belong to R as well, right? So over here you can see that 1, 2 belongs to R. So 2, 1 has to belong to R as well, which it doesn't, right? 2, 1 is not there. So you can say that R is not symmetric. R is not symmetric, right? So therefore R is reflexive and symmetric is wrong. So now let's see if R is actually transitive. To be transitive, basically the condition is that if A1, A2 and A2, A3 belongs to R, that should imply that basically A1, A3 also belongs to R for all A1, A2 and A3 belonging to A. Which means that for example here you can see that 1, 2 and 2, 2. So here what's important is that basically this A2 and A2 are common between these two ordered pairs. So if that's the case, then basically A1 and A3 are coming from here and coming from here, right? If that is the case, then these two should constitute an ordered pair. If that's not the case, then it's okay. Which means that, for example, 1, 2, 2, 2, you see that these two 2's are common. So 1, 2, 1 and 2 should constitute an ordered pair, which is 1, 2, which is actually the case here. Or now I need to be looking for basically a 2 here. Since this ends with a 2, the other pair has to start with a 2 so that they go together. So I don't have a 2 here anymore, so this one is taken care of. And by the same logic, this one also ends in a 2. So then again, we have no pair for this that's taken care of. This is a 1, and it goes with this one, and this one. So 1, 1, 1, 3. So 1, 3 has to be the case. So that is okay. And then here you have a 4, and you have no 4's here. So this is taken care of. And here you have a 3 and 3, 3, 3, 2. So that means that then 3, 2 has to be the case. So that is also taken care of. So we have no problem with transitivity, which means that R is actually transitive. R is actually transitive, which means that R is transitive and is reflexive and transitive, but not symmetric. So B is actually the correct answer, and so therefore this is also the wrong answer, because since it's not symmetric, then it cannot be an equivalence relation. So then you can say that the correct answer is B, right? Now the next question that we have here is question number 16. Which is, let R be the relation in the set N. So that is exercise 16. So let R be the relation. Let R be the relation in the set N basically this is N of natural numbers given by R is equal to basically all the ordered pairs A comma B, such that A minus B is equal to B minus 2 and B is greater than 6. So that is basically your relation. You want to choose the correct answer. Choose the correct answer. Choice A is 2, 4 belongs to R. Choice B is 3, 8 belongs to R. Choice C is 6, 8 belongs to R, I suppose, right? And choice D is 8, 7 belongs to R, right? So basically we have this relation on the set N of natural numbers, and the relation is this one. All the R is equal to all the ordered pairs A comma B, such that A minus B is equal to, I'm sorry, this is not actually correct, such that A is equal to B minus 2, and basically B is greater than 6, right? So what that means is that the values for B has to be greater than 6, meaning that the values of B are 7, 8, 9, and so on and so forth, all the way up to infinity. And so what that means is that you will get this set as if you subtract 2 from B, you will get A, right? So that means that you will get all of these ordered pairs at 5, 7 and 6, 8 and 7, 9 and 8, 10 and so on and so forth. That is your R. So 2, 4 of course doesn't belong to R, because here we are saying that B is greater than 6, so 4 cannot, that's not an option. 3, 8 does not belong to R. Here again we are saying B is greater than 6, but then this cannot be an option based on this condition that we have here. The difference between A and B is actually 2, not 5. And over here 6, 8 is actually belongs to R, and 8 comma 7 of course does not belong to R. So the correct answer is C. The correct answer is C. Right. Okay. So this was the end of these exercises. In the next video we will talk about types of functions. I'll see you in the next video.